We can use the Excel files to solve systems of equations. First, make sure you enter your name because you get a point for that. We're going to use Excel Solver with multiple entries. Let's see how it works here. The first thing that it says to do is to enter the x and y coefficients and the constant values into their respective spots. So we have 3, 2, and 13, and then 4, -1, and -1. Then it says in the cell reference, type the formula. So it is going to be the x coefficient, 3, times the x variable, which we don't know yet, plus the y coefficient, 2, times the y variable, which we don't know yet. Do the same thing for the second equation. The x box cell times the x variable plus the y coefficient box times the y variable. And once we get those two typed in, we're going to highlight the two variables, click on the solver, and we're going to set the constraints to be set the variables, the parameters, to be where our x variables are. And then we're going to make our matrices equal to each other. Our constraint matrix is going to be equal to our cell reference matrix. Right now it's not, but when we use Solver, it tells us that it found a solution, and the solution was x is 1, y is 5. All right, let's do the same thing with dependent and inconsistent equations. We're going to see what happens when we've got dependent and consistent equations. Make sure you fill in the values, and then our cell reference is going to be the equation, the x times the x variable. I'll tell you what, why don't we copy the cell references from up here because they are in the same spots, and then we won't have to type them over again. And highlight our two things that we're going to use for Solver. Those two cell references, according to the constraints where these two boxes are equal to these two boxes. And when we do, it tells us that it found a solution. Well, in fact, it found one of infinitely many solutions. So even though it says that it found a solution, it doesn't know that there were other solutions it could have found. Let's see what happens if we have an inconsistent equation. -2, -6, and 3. And then let's just copy these cell references again so that we don't have to retype them, and paste them into those boxes. And we're going to change the solver again so that we're going to have those variables according to the according to the constraint where these two are going to be equal to the cell references. And when we press Solver now, it said it could not find a solution. And when it can't find a solution, we would say there is no solution. Next one. Okay. You can do the same thing for a 3 by 3 matrix. 4, 8, 1, 2, 1, 7, -3, -14, and the last one is 2, -3, 2, 3. The problem is the cell references get pretty clunky. The x coefficient times the x variable, plus the y coefficient times the y variable, plus the z coefficient times the z variable. You have to do that for each equation, and like I said, it gets pretty clunky, but you see the box up here in the corner that you go through to tell you what to multiply, and what to add. The other thing you can do, if you want to, is to just copy the equations from here. If you notice, I could just copy this and paste it there, and then I didn't have to multiply them. It's kind of a cheating way, but it works. Solver, we're going to change the constraints to these three being solved by these three values being equal to the cell references, and and we get -3, 1, and 6. We didn't put the 1 in the right spot. And the 6 we didn't put in the right spot either. Okay, next one. You can also solve systems using matrix formulas. We still enter the values the same as before, 2, -1, and 6. For the second equation, we have to get it into the standard form where x is first, y is -1, and then the constant is 2. Now, in matrix multiplication, we've got the coefficient matrix and the constant matrix and the answer matrix. We're going to use the inverse of the coefficient matrix, or M inverse. So in our x and y variables, we type equals matrix multiplication. We're going to solve this by multiplying the inverse, M inverse, of the coefficient matrix by the answer matrix, Control Shift, and then when you press enter, you will get 4, and 2. All right. We can do the same thing with a 3 by 3 matrix. 4, 8, 1, 2. 1, 7, -3, -14, 2, -3, 2, and 3. So we're going to matrix multiplication, the inverse, M inverse, of the first coefficient matrix by the answer matrix, Control Shift enter, and we get -3, 1, and 6. You can also use it for a 4 by 4 matrix. 3, 1, -1, 1, -3. It just takes you longer to enter the data than it does for the computer to get the answer. Make sure you copy it down correctly. I know I've made mistakes while doing the video that I've copied things down wrong, and that's why it's nice if the computer shows us what we're supposed to 2 and -7, what the correct answer is. So let's highlight the answer cells, equals matrix multiplication of the inverse of the coefficient matrix by the constant matrix, Control Shift enter, and we get 2, 0, 1, and 4. The reason it says -0 is that that value actually, if we were to extend it out, would be something like point something to the -14th. It's a very small value. Let's try -0 there. No, we got the first one. Oh, it's just supposed to be -2. Now we get all the points. So when you are done, save it and hand it in.